It's my great pleasure to welcome you to our yearly virtual open house. The funny thing is that we started doing virtual open houses even before the pandemic started. So it was a very smooth transition for us. And the reason why we prefer to do virtual open houses because so many applicants, so many students are international. So it is a great opportunity for us to have this conversation. All right, so what I'm gonna do, I'm gonna tell you quite a bit of details about our program. In the way, the format in which I want to do so is to go through the brochure that you have on the screen right now. And this is the same brochure that you probably already have. This is the same brochure that you can download from our webpage. So you can always go back to it and check out the details that you missed or you want to verify. All right, so what is it that you see on the very first page? You see very important information about our program. We are applied physics program. And actually, it turns out that there are not too many applied physics programs in the United States. I believe it's about a dozen of them. And there are many features that make us unique because of that applied physics flavor. So right away, I'm going to tell you that we offer a graduate master degree and we offer graduate PhD degrees, and both of them come in applied physics. So what does applied physics mean? So first of all, applied physics provides the bridge between theoretical, fundamental physical concepts and their practical and engineering applications. And this is very, very important point. But for us, applied physics flavor or applied physics program also means three components. So first of all, it's our research focus. We do focus you know what, guys, just give me 1 second because I'm having a little bit difficulty here managing my discussion with you and also admitting people. So I'm just gonna take a quick minute here to clear out those people who just entered the waiting room, and I'm gonna go back to our research focus. So once again, we are focusing on the applied area of physics. So we are strong in solid state physics, we are strong in materials physics, in biophysics, we specialize in medical physics, AMO, which stands for atomic molecular physics, and optics. We do have a lot of effort in computational physics. These could be considered as applied areas of physics. But yet, if you take a look at these areas, you will not find some traditional areas such as high energy physics or astrophysics, because they're just a little bit less applied and a little bit more fundamental. So they are not in the scope of our program here. The second component that you can see right here, which in my opinion is very important and the one that students find quite helpful, is our tailored coursework. So let me tell you quite a few details about this tailored coursework. So first of all, in order to meet the requirement for your coursework, for your PhD graduation, you will need to take 12 courses. And this is pretty much standard throughout the United States. However, what is special about our program, that out of these 12 courses, only 4 courses are core courses or mandatory courses. What that means that only 4 courses we ask you to take no matter what. The rest of the coursework is going to be your elective. So as far as the core courses go, we will ask you to take quantum mechanics. We will ask you to take mathematical methods and physics. We will ask you to take statistical mechanics and electromagnetic theory. But that's it. This is what will provide your foundation. This is what will provide your background, because you will be graduating with PhD in applied physics or with master in applied physics. But the rest of the coursework, it's your elective and it's entirely up to you. And in my opinion, this is a great advantage because you will be fully, well, or I should say you and your research mentor will be fully in control of the courses that you want to take. And think about the advantages of that structure. Let's say your research is going to be in the area of biophysics. Then you will probably want to take biophysics 1, you will probably want to take biophysics 2, and we don't want to impose on you to take quantum mechanics too, because chances are that you're not going to be used for your research, and we don't want you to spend time on something that may not be very applicable to what you do. The same thing for solid state or materials physics. If you're doing research in those areas, of course, you will want to take solid state physics 1, you will want to take solid state physics 2, you will probably want to take material physics 2, but some other courses may not be as necessary for you. So we want your coursework, we want your electives to represent your interest, to represent your research, and we want you to be in full control. We don't want to impose too many requirements on you. So as I said, there's a great deal of flexibility with the coursework, which is a very, very important point in our program. And what does that mean? So, for example, what often happens with my students, let's say they join the program and they decide to do research in my group, and I'm going to tell you right away that my research is on computational physics, and I will be referring to that every now and then. So let's say a student joined our program and he wants to do research in my group in computational physics. Then what's going to happen? I'm going to tell the student, look, don't take 3 courses per semester. Take only 2 courses per semester and take 1 course as independent research, or, actually directed research, I should say. And that works great for my students because, first of all, it helps them to better focus on the courses that they're taking. They don't feel so much stress or so much pressure. But then the advantage also that they can get engaged in research right away. But, some advisors will be different. Some advisors will tell, look, for our research, it's much better if you complete all of your coursework in the first 2 years, and then you will devote yourself entirely to research. And that is perfectly fine for us. Some advisors, I'm talking about hypothetical case, but some advisors may tell, look, actually, I want you to take 1 course per semester. It's going to take you 4 years to complete your coursework, but you will be able to get productive in research right away. So it's going to be almost entirely your decision and decision of your advisor how you will want to structure your coursework. Because our ultimate goal, our highest priority is for you to be successful as a student. And whatever serves that purpose, we will work with you to make that happen. Another part that makes our coursework is fairly flexible is that not only we don't tell you when to take courses, we almost don't tell you which courses to take, but we don't even tell you where to take those courses from. For example, maybe you want to take courses from different departments. We are very multidisciplinary in our research, and we want you to take courses from other departments. Again, I'm gonna use example from my group. My own student, she wanted to take a course on quantum computing, and the course was offered from computer science department. That was no problem. That was a great experience for you. So she took a course from computer science department. My other student, he wanted to take a course in computational modeling that was offered in chemistry department. And that was really wonderful because it helped them to gain different perspective. It helped him to get different experience. It helped him to see modeling from the point of view of chemists. So that was very valuable. My other students took a course again in quantum computing, but she took it from math department. So the point that I'm trying to emphasize here that, that we try to keep up with everything that's going on. We try to offer coursework that is that kind of mirrors what's going on right now, mirrors those areas that are in demand. And we want you to take advantage of that. We want you to take courses from us. We want you to take courses from other departments, whatever helps you to learn, to get better and to be successful. Again, I'm just gonna take a very quick minute here to admit a few more people. So what else flexibility in coursework mean? Let's say you already completed your coursework, but then we offer a new elective that has not been offered in the past, and you want to take that elective. There is no problem with that. In fact, you can take as many courses throughout your career as you'd like, and we'll pay for that. And that is great opportunity because, like, for example, last spring, I offered a new course in density functional theory simulations. That course has never been offered. And I had quite a few students in my class who already completed their coursework, but they wanted to take the course because it's important, it's interesting, and it has never been offered. So again, we give you the full control. Again, we'll let you to decide how you want to go about your coursework. So as I said, we try to stay very modern in our course selection. Just a few more examples. Machine learning. As you know, machine learning right now is a big thing. Artificial intelligence, it's everywhere. Of course, we have different departments that are offering this course, computer science department, of course. But here in the physics department, we also offer machine learning because this is very new, but it's also something that is very, very important. So we try to make sure that our coursework is representative of what's going on in science. One more course that I should mention because it's one of my favorite and it's extremely important for you as a prospective student or future student in the program. We actually offer a course that has a title, STEM Professional Development. This is a very unique course. Very few programs offer that course, but it is extremely important. This is what happens with this course. In fact, you're going to take this course in the fall. If you were to join our program in the fall, this is the first course that you will be taking. And what will happen in this course? Oh, I think I just closed my participants. So just give me one more second here. I have to open them. So you will learn about scientific writing. You will learn about scientific reading. You will learn about presenting your scientific result. But this is just one component of the course. You probably know, you've already made that decision to join a graduate program. And oftentimes we make that decision to join graduate program because we love learning. We cannot imagine our life without learning or doing research or doing something which is challenging, motivating. This is something that keeps us going. But as we make that decision, it's not very often that we actually ask ourselves a question. What are we gonna do once we graduate with our PhD in physics? 5 years or 6 years or 7 years later, you have your PhD in physics. What are you going to do with that? And that STEM course that you will take in your very first semester will actually tell you about different career options that you will have once you have your PhD earned already. So that is another component of the course, but there is one more component which is equally important. So in this course, you will learn about different scholarship and fellowship and internship opportunities. And this is very, very valuable skill. You will learn how to identify those different opportunities. You will learn how to apply for those different opportunities. And in fact, in most of the cases, students do apply for at least one of such opportunities as they complete the course in STEM professional development. And think about it, this is great experience. This is not the kind of experience that you typically get, right? But at the same time, there are so many opportunities available out there for you for scholarships, for internships. It would be so sad not to be able to take advantage of that. But this STEM professional course, it will orient you. It will give you idea about different opportunities and how to go about them and how to present yourself and how to apply, how to write a successful application. So as you can see, all in all, this course will provide a great foundation for you to not only become a very successful graduate student, but eventually become a very successful professional. So that is another great option for you to take. And now let me come back once again here, the third component, which is also very, very important. And this component actually makes us very unique. This is an industrial practicum. So what happens here with the industrial practicum? All the students in the program are required to go through industrial practicum when they will spend maybe a few weeks, maybe even a few months somewhere doing research, learning about different things, but somewhere outside of research institution. So this is typically happens towards your graduation, maybe your last summer in the program, or the summer before last. And this is really a great opportunity because by that time you already know how research is being done at university. You have pretty good idea, but you have much less idea about how research has been done outside the university, how research has been done in the corporate world or national lab. So basically we will send you, or I should say that perhaps you will send yourself somewhere, maybe national lab, maybe some company, maybe some other industrial sector where you will spend some time doing research and learning new experiences. This is really a wonderful opportunity because think about it. So first of all, we want you to take initiative with that. We want you to actually identify those different opportunities for internship and go after them. So that is already preparation for you, for your future career, for looking for a job. Then it also allows you to build up your connection, to strengthen your resume, to gain experience. And that is really wonderful. I'm going to give you quite a few successful examples of industrial practicum from my own group, only because these are the examples that I remember very well. But there are so many from other research groups, of course. So I'm going to start with perhaps my favorite example. I had a student, so once again, my experience in computational physics is kind of important for the examples that I'm going to give you. So I had a very accomplished, I should say, graduate student. He actually did undergraduate research with me, and then he continued to graduate studies with me. And he always had his mind set on career in academia. And he said, you know what, I really like research, I really like career in academia, but I'm not that much in love with teaching. I probably don't want to be a teacher. So I think the best career path for me will be a career in a national lab. So for his industrial practicum, he went to Oak Ridge National Lab. He spent his summer there. He was very successful there. He comes back. He's extremely excited about things that he has seen there. He tells me, look, they do this and they do that. And this is so wonderful. There's so much collaboration going on, that they have state-of-the-art facilities, state-of-the-art resources. It's also wonderful. But you know what? I don't want to work in a national lab. So that was a big surprise for me because we always kind of had our minds set on him pursuing career in academia. And that was, that was a very sudden change of heart. And he tells me, look, I learned so much about career in academia. It turns out that after you get your PhD, you'll have to do a postdoc, maybe a couple of postdocs. It takes time. And I'm already 35 years old, and I still have some student debt from my, undergraduate studies and things like that. I just don't feel like, at this point of my career, I want to pursue that. I actually want to go to industry and I want to make money. I want to do research and I want to make money. Although it was very unexpected, thanks to our applied physics flavor, it was no problem for him to find a job. In fact, he found a job in the IT sector, which was very, very good. But that is not the end of the success story, because just a few months after he started his new position, he was offered a great opportunity in the defense sector to work for a defense contractor. So it's top clearance, high security. I don't even have a clue about what he is researching there, but all that I know that he is doing research, he's taking advantage of the skills that he learned in our program, but he's getting very well compensated for that. Another example of, again, industrial practicum, and again from my own group, is my another student. As she was graduating, she was not sure about what she wanted to do. She was very bright, very motivated. She said, I like teaching and I could go to academia, but I also like, some untraditional research, and I could consider those things as well. So for her industrial practicum, she was very proactive. In fact, she identified the opportunity herself. She comes to me and she says, you know what, I actually want to do my industrial practicum in a hospital. I already found the opportunity. It's really great. I'm going to go there. I'm going to do this and this and this. So she spends the entire summer there. As far as I recall, she worked on the optimization problem, and with her computational expertise, it's a great option for her. I believe that she solved the problem. I believe that she really impressed people there. I do believe believe that the offer was there for her or getting ready there for her. But, she comes back and she said, no way, I don't want to work there. Interesting. But, for her, she realized that something that she wanted to explore did not quite work for her and she doesn't want to go there. It turns out that the career path that she chose was in a financial world. And it turns out that in financial world, they use quite a bit of physics. They simulate, they solve differential equations, they use Monte Carlo techniques, something that we do here all the time. But here's another thing that I want to mention about applied physics program that we have here. Through this industrial practicum, we have a lot of partnership, and one of the with corporate world, with industry, and one of the partnership that we have is actually with Citigroup, and Citigroup is one of the largest financial institutions in the United States, and they have their campus, one of their campuses right here in Tampa, and that campus is just full of our graduates. They really love our graduates. They can never have enough of our graduates. And just literally last week, I got another email from them asking for more of our students because they have another position open. So we have that strong partnership, and naturally, the student who I was talking to you about, she decided to go there. As she joined that institution, her starting salary was higher than what I'm making right now here after 13 years being in the department. And, she was so successful there that after 2 years, she got promoted to VP. And then soon after, she got another promotion. She moved to New York, to Wall Street. So she's still working with them, extremely successful, making a lot of money. But what is most important, that she is taking advantage of the skills that she learned in the program. And, she is having a great career there. Perhaps I can give you one last example. I know I've been giving quite a bit of examples, but this is important. Again, from my group, I had another student, very motivated, very good. And then with him, what happened, his last summer in the program, his wife got pregnant. And he tells me, look, you know what? I feel like I have to stay here with her. I don't want to go somewhere outside of Tampa. And he identified his own industrial practicum option. It was actually with Moffitt Cancer Center. Many of you know that we have Moffitt Cancer Center here on campus. We hope we have strong partnership with them. In fact, our medical physics concentration is offered through the Moffitt collaboration and partnership. So anyway, my student, he goes for his industrial practicum to Moffitt Cancer Center. He does wonderful things there, really very inspirational, very interesting. They actually do quite a bit of modeling there. I believe that he used Monte Carlo to model cancer tumor growth or something like that. I'm sorry, I'm not in a position to talk details about that. That is so much outside of my expertise, but that was wonderful experience for him. And here's the point that I'm making. After he graduated, sure enough, he gets an offer right away from healthcare center. It's a wonderful offer. He's been with them, I believe, for 8 years or so, very happy climbing up corporate ladder. But here's the point. After he joined the company, they told him that, look, the reason we made you an offer, it was because you had that exposure to healthcare center, you had that exposure to medical physics, which was very valuable. So you can see how that industrial practicum really advanced his career opportunities. So, and of course, there are so many cases like that. And coming back to, once again, to the industrial practicum, to applied physics flavor of the program, as well as our tailored coursework, I'm going to give you just one more example from my own group. I have another student, and she is in fact graduating this semester. She just defended her thesis. So her success story is that she applied for some of the fellowships and scholarships. I think she kept applying throughout her career here, but after her 3rd year in the program, she was awarded a very prestigious Department of Defense Smart scholarship. So that scholarship is really great, but just a few highlights that I want to convey about this scholarship. Because we are applied physics program and we are doing research in applied physics. For example, my research, it's in the area of ferroics. In ferroics, they find numerous applications. Any application you see around, probably it will use ferroics. So naturally, there is a lot of research is being done on ferroics. So now coming back to that student, her scholarship is from the Department of Defense and they're very interested in heroics. So now the scholarship not only provided her, stipend, which was great, it also provided her industrial practicum at the Army Research Laboratory. And not only that, the best, in my opinion, the best part of the scholarship is that they provide employment for her. As soon as she graduates, and this is happening this spring, she already knows her employment, she already knows where she's going. She's going to Army Research Laboratory, she already knows her department, she already knows people she's going to be working with, she already started the projects through that industrial practicum. So this is another success story that shows you that having that applied physics component gives you, at least in my opinion, those extra opportunities. I know that many of you right now thinking that, you know what, I probably want to pursue career in academia and become professor, which is wonderful. Many of our graduates do just that. But at the same time, having applied physics component will give you a little bit of extra, will give you a little bit of that cushion or protection if you do have a change of mind, just like one of those students whom I mentioned to you in the examples. So once again, to emphasize, the applied physics flavor for us means our research focus, which is applied, our tailored and very flexible coursework, and our industrial practicum. And now, thanks to that, we have very high graduation placement rate. If you take a look at this number, you can see that 95% of our students already have a job offer as they graduate. And I do credit that to applied physics component. And I also credit that to the fact that we are very much student oriented. We want to give you skills. We want to teach you. We want to educate you in such a way that you are very marketable, that the skills that you gain is something that could be very applicable at the job market, something which is desired, something which will make you very competitive. All right, so let's move on. Let me briefly introduce our university. I know that I've been talking about applied physics, but I haven't even mentioned about the university, and there are quite a few things that I want to mention here. The first thing that I'd like to start with, we are very young. The university was established in 1960. That is going to be important for us. We are very young. But take a look at what we have achieved. We have been named America's fastest rising research university. So I'm quoting 2020. I'm pretty sure it was the case in 2021 as well. We just haven't updated this brochure. But think about it, how exceptional it is to be recognized as America's fastest rising research university. That tells you right away about our momentum, right? That tells you right away about our trajectory. Now, take a look here. A few years ago, we have received a very high designation from the state of Florida. We are now one of only 3 Florida preeminent research university. So this is very high recognition. It was hard for us to get there. We had to meet a lot of metrics, but we made it there. And look at the company that we have here. We have University of Florida, which is very, very reputable university. We have Florida State University. But think about it. Those guys, they're twice our age. We are just half their age. So we are youngest and we are already there. That tells you once again about the momentum and trajectory that we have. And this is something that I personally like very much. If you look around the university, if you look around the department, you can feel that momentum. You can feel that, dynamics. You can feel that, kind of attitude, I should say. We are very young, but we are very ambitious. We want to get on top. We want to get on top very fast. We like to challenge ourselves. We like to make a difference. So you could actually feel that. And now think about yourself. Are you a person like that? Do you like to challenge yourself? Do you like to be a part of something that is rapidly developing, something that is, has a great growth trajectory? Do you want to be the person who will make a difference? Do you? If yes, you should absolutely come and work with us. Do you just want to get your PhD degree and not to worry too much? Do you not want to challenge yourself? Do you not want to be extra motivated, extra hardworking, and make great things happen here? Then you probably should go somewhere else. So the point that I'm making here that, guys, we're very young, but we're very ambitious. We are trying our best. We challenge ourselves. We want to get better and fast, and we want you to be part of that. If you feel that momentum, if you share our aspiration, that would be so great to have you here. So just a few more things that I want to mention here. So we are classified as R1, doctoral university, very high research activity. Only 2.5% of post-secondary institutions have that. But you know what, before I forget, I should mention something which is very, very important, something which is happening just as we speak. So we have a new leadership. And this new leadership is absolutely special. So we have a new president who is very special. We absolutely expect wonderful things. They've already been wonderful things happening here at the level of state, at the level of legislature, we're getting more funding. So you see, with that momentum, with the new leadership, that is absolutely wonderful. I think we should expect even more things happening. I could not be happy to be here at this very moment because the expectations are very, very high. Let's talk a little bit about the physics department. So right now, I believe we have 25 or so faculty in the department, and we have about 65 graduate students. Take a look at that. I know that you are all good in math, and you can do the ratio. So you can see it's roughly about 2.5 students per faculty, and this is wonderful ratio. I know that from my own experience. Whenever I have a very large group, number of people comes and go. Whenever I end up with very large group, I find myself less productive. I find myself enjoying less what I do because it's a lot of management. It's less time for my students. It's less time for my postdocs. I personally don't like it. But having small sized group is wonderful because you talk to your students, you get to learn together with your students. You always, I shouldn't say always have time because reality, you never have time. But at the same time, this is something that allows us to be more productive. And that is something that allows us to be oriented on the success of our students. One more thing I want to mention here. So we have been, we were, how should I put that? We were designated as one of only 2 inaugural BRIDGE program. You probably don't need to know too much about BRIDGE program, except that this is a very prestigious program whose focus is to make sure that there is diversity in the STEM field. And we have been recognized as one of just 2 inaugural sites because we are very committed to diversity. We are very diverse. Here in the department, both faculty and students, we have people of color. We have a lot of female students. In fact, there is something to be proud of. We are right now the top producers of female PhD in physics in the United States. So right now we have about 30% of female students in the program, which is a very high number. So not only we're very diverse, we're very committed to the diversity, we're also very international. Our faculty is from all over the world. Our students are from all over the world. And this is important because I know that many of you will be coming from, other places in the world. And some of you may feel like, oh, you know what, I'm not sure, it's a big transition, how I'm gonna fit in. You're gonna fit in great because you come here and you become part of the family because students are from all over the world. They all are in the same situation. And our students are really great because they're so supportive. Even as you receive your offer, chances are that you will get emails of our students. You can talk to them, you can ask them different questions. They're awfully supportive. You come here and you become part of the family. They have different functions. Absolutely amazing group of students. All right, so let me move on. So just a few points again that I'm going to reiterate. So we offer graduate programs, we offer MS program in applied physics, and we offer PhD in applied physics. There is one distinction that I want to make here. Sometimes students believe that in order to apply for PhD, they already need to have master. That is not true in United States generally, and that is not true for our institution. If you have your BS in physics and it took you 4 years to complete your degree, then you can apply for PhD. So when you make that decision, whether I should apply for master program or I should apply for PhD program, it should be your decision. What should be my terminal degree? Do I want to earn master degree and that's it? This is where I want to stop. This is going to be perfectly fine for my career. Or do I want to earn PhD degree? So my terminal degree is going to be PhD degree. And that will tell you for which program to apply. If you believe that you want your PhD degree to be your terminal degree, you apply for PhD directly. You don't need to apply first to master program and then to PhD. But if you do believe that you only want to get master from us, then you apply for master program. So this is a misconception that many students have. They apply for master program, although the intention is actually to continue to PhD program. I should mention that as far as financial support goes, we give a bit more preference to students who apply for PhD rather than to students who apply for master. Now, another program that we offer here is PhD in applied physics with emphasis on medical physics. In fact, right now it is called PhD in applied physics with concentration in medical physics. So this is a very special program. It's small, but it's very special. It's very competitive program. Every year we get quite a bit of applications for this program, very strong applications, very competitive. Typically, because it's a small program, very selective program, we can only accept at most one student per year due to different limitations. So, but this is program which is really great. All right. And by the way, I should mention that our medical physics concentration is offered in collaboration with Moffitt Cancer Center. And I'm going to give you a little bit more details about medical physics as we go through this presentation. So this page just lists different areas that we specialize in. I already mentioned them. I'm going to mention them just once again quickly. Solid state and materials physics, we're very strong in that. We have a lot of research effort there. So biophysics and biomedical physics. So here I want to make a quick stop, because sometimes when students are interested in those research areas, they will apply for our program, but they will choose medical physics concentration. However, it should be separated. Medical physics concentration is different from just our core program where we specialize in biophysics and biomedical physics. So if you're interested in biophysics and biomedical physics, so make sure that you do not select medical physics concentration. If you made that mistake, you can just let me know and I can transfer your application to our core program. So medical physics, so once again, it's in collaboration with Moffitt Cancer Center. So what's happening with the medical physics program, you join our applied physics program and you will take 4 core courses with us. Once again, the core course is going to be quantum mechanics, mathematical methods in physics, statistical mechanics, and electromagnetic theory. But beyond that, you will be under care of medical physics program. You will take all your electives from medical physics. Of course, you will do your research in medical physics, you will do your research in Moffitt, and you will be guided by the medical physics faculty. All right, so if after all this you are still not convinced that USF Applied Physics program is the best place for you, I'm going to give you a few more highlights. But remember, we don't want to convince you that this is the best program for you. What we want to do with this presentation, we want to educate you about what we have to offer. But of course, it's up to you to decide whether what we have to offer is the right choice for you. All right, so just as a summary, Once again, I cannot emphasize it any stronger. We are applied physics program. And as you've already heard, there are quite a few differences that come with that flavor. So we are ranked among top US programs for student criteria. This is our National Research Council ranking. What does that mean, student criteria? That includes many things such as student graduation rate, graduation time, graduation placement rate, other many things. But for me personally, what it tells that our students are simply happy in the program. They're successful, they enjoy their time here, and they are able to take advantage of this. So I already mentioned that we have very high graduation rate and graduation placement rate, over 95%. This is very impressive. One thing that I did not touch upon is actually the time that it takes you to graduate with PhD in physics. I'm going to start with the fact that the national average to earn PhD in physics here in the United States is 6.5 years. We are a bit ahead, actually a year ahead of national average. So our average to graduate with PhD in physics is 5.5 years. And I credit that again to our commitment to student success. So I already mentioned that we keep our groups small so that we have adequate time for our students. We're very committed to student success. So just to emphasize that point, you come to the department and you become part of research group. Of course, you will have your research mentor and everything. But in addition to your research mentor, we also have a director of the graduate study. And he is the person or to go to person if something is not working out for you in the program. It doesn't happen very often, but sometimes, rarely, you join a group and you realize that you just cannot be productive in that group, or something is not working out in that group, or you just cannot find, the right way to communicate with your advisor. Then it's not a problem. You're gonna go and you're gonna talk to the director of graduate program, and he's gonna work out on the solution with you. Or other cases, again, they don't happen very often, but let's say for one reason or another you had bad semester, something happened, and you go on academic probation. Again, we'll have a person who will help you to get out of that situation, who will work with you, or any other situations that might happen. It's not like you're completely on your own here. We have a very good support system here in the department to make sure that our students are successful. And another role of our director of graduate program, he will keep another eye on you. Let's say if for one reason or another, you're taking your sweet time to graduate, right? And it's been 6 years and we are not hearing that you're graduating, right? So he's going to talk to your advisor. He's going to talk to you. He's going to make sure that things are moving along. There is some help you need or anything. We're just going to keep an eye on you throughout the program. We're going to advise you. Director of graduate studies, or, you can come to me. We will always try to help you as much as you can. So we try to have a good support system for our students. So I already mentioned multidisciplinary research. We have a lot of collaborations that are going on in the department and outside the department. Perhaps I can give you another example from my group. So my research interests are in the area of computational physics, of multifunctional materials. And what we have this big joint project where we do computational research on hybrid ferroelectrics, which is a very new thing. And then we have people in the chemistry department who synthesize those materials for us. And then we have people in the physics department who actually do the measurements. And we have that collaboration, multi-department, multi-institutional collaboration going. And we have many examples like that in the department. Of course, collaboration with the Moffitt Cancer Center, especially if you do research in the area of biophysics. There are plenty of opportunities here. And actually, we want you to take incentive there. You come to the department, you join research group, you see potential collaboration with someone else. We want you to take initiative there as well. So now something very important, we offer comprehensive financial assistance. So what does that mean? The first thing, as you get your offer, or maybe somebody already have quite a few offers. I know it's already late in the cycle, so you probably have your offers. So how do you look at your offer? How do you look at your stipend? Please remember that in United States, the cost of living varies very much by state. There are states that are very expensive, like New York or California, and there are states that are relatively cheap, like Florida, for example, is one of those low cost of living state. In fact, it's so good that we don't even have to pay state tax. So typically the stipend that institution offers, it will go in hand with the cost of living. So you may get an offer from an institution in New York, and your offer will, and that other offer will probably offer twice as much as we offer, but that does not tell you anything until you weigh it against the cost of living. I typically say that here in Florida, you can stretch your dollar much farther than in many other states. So please keep that in mind as you assess your stipend. So first of all, your stipend should never be a decisive factor because you're choosing the program, not the financial support. And pretty much any program will provide you enough financial support to make your living here. But as you compare, if you do think about that financial aspect, and if you're comparing different offers, please weigh that against the cost of living. Talk to the current students in the program. Ask them how much it costs, to rent an apartment, or, even the cost of food and things like that, and see how your stipend fares against those costs. So a little bit more meaningful comparison would be to take a look at the offers from the same state. And I do know that we offer second highest stipend in the state of Florida. So this is what we mean by competitive stipend. So we offer tuition waiver, you don't have to pay for that. We offer health insurance. I feel like, yes, there's one very important point that I absolutely must convey about financial support. We are very financially responsible for our students. So this is what happens. Every now and then we get application, and we get an application from a student who already in PhD program in the United States, he's leaving the program and he's applying to our program. And this is concerning, right? You would think, why would somebody want to leave a program and, go somewhere else? And it turns out that when we talk to the person, it turns out that his advisor ran out of funding and the person just simply has to look somewhere else. So here, fear not. Things like that never happen to us. We're extremely financially responsible. There is a reason for that. We have a very large number of teaching assistantship because we teach a lot of service courses. So that means that even if your advisor runs out of funding, that's never a problem. You will be just switched from research assistant to the teaching assistant, but that's no problem. You never have to worry about finances here. As long as you are in good academic standing, as long as you are working toward your PhD, there is absolutely nothing for you to worry about regarding finances. We will take care of that. So we already talked a lot about tailored coursework. We talked about industrial practicum. I did mention that we're one of only 3 preeminent state research universities in the Florida, and we are the youngest among those guys. But thing that we did not get to talk about yet is that we are located in the beautiful Tampa Bay area. There is just not enough good words that I can say about area. I've traveled a lot. And still, I've seen many beautiful places. And still, for me, Tampa, Florida is the best place in the world, literally, because there's just so many things to do. So first of all, we're medium-sized city. Medium-sized city means that the crime rate is low. You don't have to worry about things like that. But still, we have a lot of things to offer. We have beautiful downtown with exceptional riverfront. We have the top beaches in the United States. Both you can reach the beaches on the Gulf of Mexico and the Atlantic coast. We have amusement parks. We have amusement parks right across campus, Busch Gardens and Water Park. We have many different recreational facilities such as parks and, even different farms, so many things to do. There are always some kind of festivals going on. There are a lot of sport. There are so many recreational things. And you may not consider that seriously right now, but believe my experience, it does matter. You do come here to work hard. You do come here to do your best and to be the most successful person you can. But that will never happen if you don't have adequate time to relax, recharge, and rejuvenate. If you work extra hard non-stop, you will get burned out. And we don't want our students to get burned out. We want them to work hard, but then take breaks and go enjoy and, get a lot of recreational options so that you can refresh, recharge, rejuvenate, and come back full of energy and again, work hard. So things like that do matter. So I'm just gonna tell a few more things. So this is about the application. I know that some of you will be applying next year. Some of you may be applying, a couple of years from now. So just a few things that are important. Of course, you can read about them through this brochure, but a few things. So first of all, as far as English goes, you absolutely must meet the English requirement, but that is not the end of the story for the English. Most of our offers, they come as offer of TA, which is teaching assistantship, which means that you come here, you're going to be teaching labs or courses, and that is what will provide your financial compensation. I should mention that actually TA offer is great opportunity because this is the opportunity for you to put teaching on your resume. And this is something which is very important because perhaps you graduate and you decide to go to university. This is where your teaching experience will really matter. And as teaching assistants, we want you to be the best teaching assistants possible. And we provide incentive for that. We have awards for best teaching assistants. We really have recognition. So if you do well as teaching assistant, we will provide recognition. You will put that on your resume, and this is something that will really help you if you will pursue career in academia. But coming back to this teaching assistant, this is what happens. The state of Florida wants you to be a great teacher, and it's a little bit harder to be a great teacher if you have some, limitations with your language. To ensure that the students who come to your classes get the best education they can, the state of Florida imposed the following limitation on your speaking skill. So if you are looking for financial support from us in the form of teaching assistantship, you need to meet this minimum speaking scores on the test. All right. So here's the quote for our current stipends, and every now and then we're able to offer a little bit more than that through different fellowships and scholarships. We do have some of them. If you believe that you are exceptional or outstanding candidate, so we're gonna ask you to apply early on before December, so that we can screen your application and nominate you for one of those fellowships that we have available. So we also have some summer fellowships. So just a few more things that I want to emphasize about the program. So what happens once you are in the program? I know that this is a very important, and this is very important part of the consideration. So once you are in the program, this is what will happen. We will ask you to take 12 courses. And as I said, there's going to be a lot of flexibility on how you want to do that. So 4 of them will be core courses, and 8 of them are going to be elective courses. So a typical path when students complete their coursework in 2 years, but as I said, you don't have to, then in the first year, there will be very big decision for you to make. There will be decision of joining a group. This is very important. This is the biggest decision of your PhD career. And by the way, remember I talked to you about the STEM course. So part of the STEM course will talk about that decision of joining research group as well. But this is what's going to happen. Let's say you join us in the fall. In the fall semester itself, we will send you through the lab rotation. So already now you can check our department, you can check out different faculty, you can see, their research, you can see what is it that is most motivating for you, most engaging for you. But one thing to keep in mind, once you're here, it's not all research labs that are going to be recruiting students. Remember, we try to keep that ratio low, 2 to 3 students per lab. So perhaps the group that you're really interested in is not recruiting students. That is the option. So we're going to tell you which groups are recruiting students, but typically we have at least half of the department looking for students. It's not like you're going to have just 1 or 2 options available. There will be quite a bit. But basically, in that very first fall semester, you will go and visit different groups that are recruiting students. You'll get to talk to the professor. You'll get to talk to the students. You can attend group meetings. You can do anything you want to learn as much as you can about different research options that are available for you, about different research groups. So it's going to take your the entire fall to go through different options. But then in the spring, this is when we want you to think really hard start, this is my option A for the research group, this is my option B for the research group. And in the spring, you probably want to start attending group meeting of the group that is your highest priority, learning about the research, making sure that this is what you want to do. Or perhaps you even attend two groups so that, you know, you can kind of have several options for available for you. Now, your first summer in the program, you will join that group. And in the summer, you will have more time. You will be able to actually get into research, try that research, see if that works out for you or not. But this is great opportunity for you to finally see how things are working out before you commit. So after that summer, if things worked out great in the group, wonderful, you'll just go ahead and join that lab. But if you did not find it as motivational as you would like it to be, you can find something else, but we try to limit that, you know, switch to one. We will let you switch once. Beyond that, it's not going to be encouraged because you don't want to do that, right? It's not a good idea to switch between groups because it drags you in your graduation. It's not productive for you as well. But the point that I'm making here, that first year is going to be very important for you because this is when you're joining your group. I know that some of you already got your offer, and some of the offers already indicate the group that you're going to join. That is great. You're just going to go ahead and join that group. But some of you just come into the program, and you will be looking at different opportunities that we have here, and you will be deciding which one you want to pursue. So in the second year, most likely you will be completing your coursework, and you will be you will already join your group, but you will start getting more and more engaged in research. And then this is something which is another advantage of our program, and this is something that just happened very recently. So qualifier. So you know that many programs for qualifier, they offer comprehensive examination. And, you know, we had that for some time, and then we had different system. And then we realized that that does not really serve the best interest of student, because you just have to do the same thing. You have to study the same coursework that you've already completed, right? So we thought that it would be best if you focus on something that is applicable for your research. And in recognition of that, we completely restructured our qualifying process. We don't require comprehensive examination, which is actually a wonderful option for you as a student. But what we require a research effort where it's going to be up to you and your mentor, but you, for example, you could have reviewed your research area, or you could have reviewed some instrumentation, or maybe you have completed some project which is instrumental in learning computational techniques that you need for your research, and you're going to present that to your committee, and the committee will decide, you know, whether you meet the required qualification. But in our opinion, it's absolutely more productive than the little bit old-fashioned system of comprehensive examination, because that part not only will prepare you for your research, but it will also give you an idea if this is something that you really want to do. Perhaps you will decide, you know what, this is so, you know, involved, and, you know, I don't see the end of it, and I really don't want to do it, right? And then you will have the option of just probably getting your master and go and do something else with your life. So we do believe that it just serves students much better than a traditional comprehensive examination, and it's actually much easier on the students as well. And we do expect you to graduate within 5 or 6 years in the program. So for the industrial practicum side, I already mentioned so many examples, but it could be anywhere. It could be in the United States. I know it chose 1 point, but, you know, that is just marketing issue. There are so many points here. They told me they can just place 1 point per country, which is absolutely ridiculous, but we have also a lot of options in Europe, in China, in Asia, and so on and so forth. So there are different places where you can go for industrial practicum. So for example, one of the recent example from one of the students, she told me that she's going to go to Germany for her industrial practicum in the summer. And finally, it's a beautiful place to be. As I mentioned, life is absolutely gorgeous. We have sunshine pretty much 365 days a year. You don't get depressed because of sunshine. It's absolutely wonderful and gorgeous to be here. The campus is, I said we're young, right? So the campus is new, the campus is ginormous. So you see, oftentimes students don't even walk on campus because it's so big, they have to ride a bike or a skateboard or something like that. It's very modern. Our building is very modern. I believe that it's still the tallest building on campus. It's full of windows, full of space for research labs. It's just absolutely wonderful to be a part of this university and of this department. All right, so let me see. I think I've covered pretty much everything that I wanted to cover. Of course, this brochure is available for you from our website. You can go ahead and take a look if you missed some of the points here. So let me just check. Yes, I don't think that I have anything else to say. So this is when I will give you the opportunity to ask questions. I'm going to stop the recording for now, if I even had that recording. Yes, so let me stop it and then I will take your questions.